Now on this board we're looking at the effect of electrical pressure and current when we connect things, different things, in parallel and series. If we look at this switch here, at the moment it's flicked over to this side and it's showing us the voltage, electrical pressure that we're getting from these two batteries, and it's about 1.5 volts. All the ammeters, the 3 ammeters that we've got here, are all showing 0 because we haven't got a complete circuit, and so we've got no flow of electricity. But when we press button A, this light's coming on and we're getting a flow round the circuit, and it's showing just under 0.3 of an amp. If we add a second light in parallel with the first one, this will also require current, and we'll see the increase in the ammeters. They've both gone up to just about 0.5 of an amp, not quite double, because it's pulling too much out of the batteries, but almost double. So when we have things connected in parallel, they both require current. The voltage doesn't really change, but the current will increase. Now, as we've said before, it's really important when we have things like bulbs that they receive the correct voltage. And all of these bulbs here require 1.5 volts. But if we connect them in series, not parallel, then the voltage we have to provide to the circuit is twice, because each one requires 1.5 volts, and when they're in series it means the voltage that we need to provide for that is the two added together. If I flick this switch across here, it's showing the voltage produced from both these sets of batteries, and that's 3 volts. So if I press button C, these two lights are coming on. Again, the current is what we had before, just under 0.3. But this time both lights are illuminating because they're both taking 1.5 volts, and it's flowing back through this meter, and it's showing just under 0.3 of an amp. And if I add this one, again, both ammeters are going up to about half an amp because we've got the current flowing through both of these. Now, if I press A and C, we're going to have current flowing through both this meter and this one. And because this is the return back to the battery and it's taking both, we'll see that this is these two values added together. If we press all 4, we'll show nearly a whole amp coming through this bottom part of the circuit and about half an amp in the top 2 meters. Now, the last thing to say is that these two batteries are connected in parallel, which is quite unusual, and these two are connected in parallel, and it's because I knew that we were drawing quite a lot of current and I needed 2 batteries together in parallel, so each was going to provide half the current. Normally when you have 2 batteries next to each other, one is the other way round and the 2 are connected in series.